Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is find the x sum of all the k-long subarrays part 2. The part 2 of the problem is considered as hard, and I would say it's actually very hard, which is fine. We are going to solve this step by step. What I want from you guys is just stick with me to watch the complete video, and you will understand the intuition behind the solution and the solution approach, everything about the problem and the solution. Now, we have already solved the part 1 of the problem yesterday, which was the problem of the day on Leetcode yesterday. The part 1 was easy, but I would say it was not easy, it was easy to medium, but the part 2 is definitely hard. And both the problems are exactly the same. The only difference is the constraints. Now, the number of elements in the nums array will be very large. I think the constraint is about 10 to the power 5. Let me just check it. Yes. So we can have around 10 to the power 5 elements in this array, in the nums array we have. Now, earlier in the part 1, the number of elements was just 50. So a brute force solution was working. Now the brute force solution is not going to work. And if you have not solved the part 1 of the problem, then I will explain you the question. But if you have solved the part 1, then I think you already know the problem, because the problem in part 1 and part 2 both are same, right? But let me explain you the problem a bit for those people who doesn't know about the problem because they have not solved the part 1. So in this problem, we are given three inputs: nums, which is an integer array, and k and x. Now try to read the problem again. We have to find the x sum. This x is given in the input of all the k long subarrays. This k is also given in the input. So we have to find all the subarrays which have the length of k. And for all those subarrays, we have to find the x sum of that particular subarray. Now let me show you the first subarray, which is k long. So this is the first subarray which is having total 6 elements, because the value of k is 6. 1, 2, 3, 4, 5, 6, right? Now, if you consider these 6 elements in your first subarray, then you need to find the x sum of your subarray. X is equal to 2, so you basically need to find the 2 sum, right? Now, what is this 2 sum, or what is this x sum? Basically, it's the sum of all the elements in this particular subarray which has the highest frequency, but you just need to consider the x elements, the top x element which has the highest frequency. So I would say just find out all the elements in your subarray and its frequency, and just consider the top x element which has the highest frequency. So you have 1 2 times, you have 2 2 times, you have 3 1 times, you have 4 1 times in your current subarray. Now, if you just find out the top 2 elements which have the highest frequency, then it is 1 which has the frequency of 2, it is 2 which has the frequency of 2, right? Take the sum of all those elements. So 1 plus 1 plus 2 plus 2 will be equal to 6, and for this particular subarray, the output would be 6, right? Let's take one more example. Let's consider that this is our next subarray. Which is our next subarray, right? It has 1 2 3 4 5 6 elements, right? Because we have to find all the k long subarrays. In this subarray, the output is going to be 10. That is, the x sum is going to be 10. How to find the x sum? You just need to consider the frequencies of all the elements, and you need to take the sum of all the elements which have the highest frequency, but just consider the top x elements, right? So you have in this particular subarray, you have a 1 1 time, you have a 2 3 times, you have a 3 1 times, and you have a 4 1 times, right? So you have 2 3 times, and you have other elements 1 3 and 4 1 times. So if you just talk about the frequency, 2 has the highest frequency, and then 1 3 and 4 have the same frequency. So you will definitely consider 2, because we just need to consider total of 2 elements. So this element 2 is having highest frequency, so we are going to consider 2. Now, what about the next element? Because we need total 2 elements, right? So the next element is going to be either 1 or 3 or 4, right? All have the same frequency. So you will just consider the highest element, which is 4. So now you got your elements, which is 2 and 4. Take the sum of all the 2 and all the 4 in your subarray. 2 plus 2 plus 4 plus 2 will be equal to 10. So that is your x sum of this particular subarray. Basically, the sum of top x frequent elements in your subarray is the x sum of that particular subarray. And when the frequencies are same, consider the element which is the highest or which is bigger. Now that we know the problem, let us focus on the solution approach of this. Now, one of the easy way, one of the brute force way would be to solve it how we did in the part 1. You can watch the part 1 of this video using the I link, but just to tell you in short, you can just find your subarray. Finding the subarray is simple, right? In the subarray, create a counter object, that is, find the frequency of each of your element, and then using something called as max heap data structure, using the heap data structure, you can just find out the next element which has the highest frequency, and you just need to consider x elements, right? That would be easy. The complete approach of this particular brute force is shown in the part 1 of this problem, and again you can find the part 1 problem solution in the iLink. But that is not going to work in this part 2 because the constraints are huge. Now when the constraints are huge, what's the approach to solve this? See, we are going to use something called as containers. We are going to use two containers, a top X container and a bottom X container, or I would say the bottom container. Now we are actually going to process each of the element one by one, right? This is our array 1, 1, 2, 2, 3, 4, 2, 3. We are going to process each element one by one, and we are going to just store their frequency in something called as a counter object. That is going to store the frequency of each of your element in the current window, or I would say the subarray. The moment I am processing the element 1, I will have a subarray of 1 element. Then I will have a subarray of 2 element, then 3 element, then 4. Then I would be having 5, then 6 element. The moment I get a 6 element subarray, I would store the X sum of that particular subarray. My target would be just calculate the X sum while processing each element. Do not try to find the X sum of a subarray completely. Just process one element at a time and keep storing the X sum of that particular subarray or the window you have explored as of now, and your window size should never be more than k. Now what are these two containers for? I will explain you. First of all, let's try to process elements one by one. Now let's start with the first element. Let's say we are processing the element number 1, or I would say the first element, which is equal to 1. The moment I will have this 1, what I need to consider is I first need to see, do I have a frequency? Do I have this element already in my counter object? No, it is not. My counter object is empty, right? If my counter object is empty, I can actually store this element in my counter object. I can say I have got a 1, which is total 1 times. This is the frequency. This is the key, which is my element 1, and this is the frequency, which is the value, or which I would say the frequency of my element 1. So this is key, my element. This is value, which is the frequency of my element. Now, as of now, I have just seen one element, right? I want to maintain two containers. That is because I actually need to just keep track of my current window and the top X element of my current window. Basically, as of now, my window has one element, right? If my window has one element, I need that in this one element window, just find the top two elements which have the highest frequency, right? If you do not have top two elements, find the top one element, right? Now, first of all, I'm going to store two containers. I already told you that, top X and bottom X, or I would say bottom. In the top X, I would keep all my elements which belongs to the top two, or I would say the top X elements having highest frequency in my current window. And in the bottom window, or I would say in the bottom container, I would store all those elements which are there in my current window, but they do not belong to the top. We just need to find the sum of the top elements, right? So if we could just distribute our elements in my current window in top and bottom, then I would have my sum ready with me, right? I would store the sum of my current window, the X sum of my current window at each point. So the moment I will see that I got a 1, which is equal to 1 times, I would first store this particular data in my bottom. Initially, I'm just going to put this in my bottom, and the way I will store is I will store a tuple, and the first element is actually going to be the frequency, the second element is going to be the element. So here we have a 1, this is my element itself, and this 1 is the frequency, because we have to give the preference to the elements based on the frequency, and if the frequencies are same, then the element itself will give the preference, right? Now try to understand this. When we have stored this data in the bottom, as of now we have just one element. This should actually belong to the top, right? It should be a part of the top because we have just one element in the window, so it belongs to the top. Now let me tell you one very important thing before we actually push our element from the bottom to top. This particular container, the top X container and bottom container, should always be sorted. Should be sorted based on the frequency, and if the frequency are same, should be sorted based on the key, right? Or I would say the element itself. Now this sorting can be done on your data. Every time you just push the elements in your data, you can sort it, but that is not beneficial. But if you can just have a container which is sorted by default, then that can definitely help, right? So we are actually going to use something called as sorted list, which belongs to a module called as sorted containers. Now if I just search this sorted containers, it's not something which is directly written in Python, or I would say it is written in Python but directly given by Python itself. It's the external module created by Apache. right? It's not provided by Python. When you install Python, you will not have this particular module sorted containers. You will actually have to install it as a external module created by Apache. Now this particular module contains a class called as SortedList, in which when you push the elements, your elements will always be sorted. Now once you have this particular class with you, let's actually import this. Leetcode does provide this particular class to be used. So we can say from sorted containers, let's should be S as well. Let's import sorted list, right? Now once we have a sorted list, let me just confirm that the spellings are fine. Let me actually just copy this from here only, right? And I can remove this. And now I just need two containers, top x and bottom x, right? So I would say top underscore x is equal to a sorted list, right? And I need one more, which is bottom equal to a sorted list. And I also need a counter object, right? So I would say counter is equal to counter. And let's actually have one more variable called as sum, which is actually going to store the x sum of my current window. So current sum will be equal to 0. As of now, it is 0. Now that we have pushed our data in the bottom, the next thing we actually need to do is we first need to see, is our current window more than, or I would say equal to the size of k. Our current window contains just one element, so it is not a subarray of which is k long. So we actually don't need to store any kind of answer as of now. But we also need to check later on that since we have a window, right, and we have something in the bottom, can I push this element, the bottom element, in the top? Does my bottom element belongs to the top? That's the question. And how can you find it belongs to the top or not? First of all, you just need to make sure that in your top container, we should have two elements, exactly two elements, not more than that, right? Now, since your top x doesn't have any element, but your bottom does have, right? And your top should have two elements. So your bottom element should actually belong to the top, right? It actually belongs to the top in the current window. So we can simply take this element and put it in the top. And the moment I will put my element in the top, I'll update my sum as well. My sum will be the frequency multiplied by the element. So 1 multiplied by 1, which will be equal to 1. So that's my current sum after processing one element, which is this one, right? That's it. Now let's process the next element. Let's say that we are now processing the next element, which is 1 again, right? When we are processing the next element 1 again, we are just going to do the same thing. First of all, we are just going to see that if the element is 1 and it's already there in my counter object, its frequency should be updated, right? But the process should be followed, right? It's not like you can just update the frequency. We have to actually update our bottom and then update our top as well. So first of all, we are going to see it already belongs to our our frequency counter object. So what you will do is you'll actually remove your element from the top for now, temporarily remove it from the top, and the moment you remove it from the top, you will actually reduce the sum as well, and the sum will be 0. But now you'll update your counter object. Your counter object says that you have a 1 2 times in your current window. This is my current window, right? My window size will only increase, but it should have a maximum of k elements. The moment I will have more than k elements, I will have to decrease the window size. So for now, the window has 2 elements, so it is fine. In this window, we have 1 2 times. So I'll just push my element in my bottom. I will say I got a element 1, which is 2 times. So we have a frequency of 2 for the element 1 in my current window. And again, the same question: is this element something which belongs to the top? So yes, this element belongs to the top, not the bottom, because my top is empty. We have something in the bottom, we can push it into the top. So this is my top now, and again I will just update my sum. The sum will be 2 into 1, which will be equal to 2. So in my current window, we have a sum which is equal to 2, and this is my element. We have element 1, which is 2 times, and that's the x sum of my current window. In my current window, we just have 2 elements. The x sum will actually be 2. We just need to find out the sum of x elements which have the highest frequency. We just have one element, we don't even have 2 elements, so we will consider just one element. Again, we are going to do the same thing now. We are just going to process the next element, I would say. So let me just take this and put it to the next element. The next element is 2. Do the same thing. Now this 2 is not in the counter object, so we will first push it into the counter object. We will say that we got a 2, which is 1 time as of now in my current window, and I would also push this data in the bottom. In the bottom, I would say that I got a element 2, which is 1 time. This is basically the frequency. This is the element. Okay. Now this process is actually building our solution. You might not be able to visualize this as of now, but just go one step at a time. Okay, do not try to rush. Now we got this element 1, no, not the element 1 but the element 2, which is 1 time, right? Again the same question, after you have pushed this to the bottom, is this element something which belongs to the top? And yes, it does belong to the top. Why? Because we have something in the bottom, right? We have 3 data as of now, right? We have 1, 1 and 2 in our current window. In this we have said that okay, the frequency of 1 is actually belonging to the top of x element, the top x element. But what about 2? The frequency of 2 is 1. Does it belong to the top elements? Yes, because in the top we should have 2 elements, we just have 1 element, right? So anything in the bottom will just go to the top. The highest elements of the bottom will go to the top. So I would just pick this element, put it to the top, and now my sum will actually be 4, right? Sum was 2. Now I added an element which is 2, which is there for 1 time. So 2 multiplied by 1 will be 2. So 2 plus 2 will be 4, right? So in our current window, the x sum is actually 4, right? And you will see that we are building the solution like this. Let me actually write the code for whatever we have discussed as of now. So this was our initial code. After that, we added some variables. Now let us actually create a function. This function is actually going to add an element in our counter object, or basically update our counter object, because we have to update our counter object multiple times. Let's actually have a function for this. So we can say def update. In the update, we should just pass what's our current element and by how much do you want to increase this. Of course, you want to increase this by 1, right? Whatever your current element in your counter, you will add it by 1. But the thing is, maybe later on you will have to remove some element from your window. So you will actually not add 1, but remove 1 from your counter object's current element. So that's why just keep it as a variable quantity. So that's my current element, and that's the quantity by which I want to update this in my counter object. All right. Now I also want to actually update the current sum later on, but let's not worry about this. Let's just worry about the counter object. I would say counter of the current element plus equal to qty, the quantity, whatever is the quantity, either can be +1 or -1. So using this, we are actually updating our counter object, and we are also going to do one thing. If there is something in the data for the current element in the counter object, that is, if the counter of the current object is actually more than 0, or I would say positive, then I would actually add my element to the bottom, right? So I would say bottom dot add. We have a sorted list. In this we have a method called as add, and what we are actually going to add is we are going to add a tuple. The first element is actually going to be the frequency, so I would say counter of my current element, and the second element in my tuple will be the element itself, right? Now before we actually do this update in our counter object, there is one more logic which you need to understand. Let me zoom it out a bit. What we actually need to do is we actually need to check that does this element already belongs to our counter object or not. So we can say if counter of current, it means if this element is already in our data, then remove it from the bottom. Bottom dot remove. We are going to use this function bottom dot remove, because later on we are definitely going to add it, right? Add the updated data. So we don't just want to add multiple data for the same element in my bottom or even in my top container. So I would remove it from the bottom before updating my counter object for the current element, if for the current element there is something in my counter object already. So let me just copy this and put it here. So the previous instance or the previous data for my for my bottom object for this particular current data from my bottom container will be removed. What I mean to say is before actually adding this one, before adding this one second time, we actually removed the 1,1 from the bottom, right? If it belongs to the bottom, we will remove it from the bottom. All right. Now what if it is not in the bottom? If the data is not in the bottom, because later on it might have been just transferred to the top, then we will have to remove it from the top, right? So we need to remove it from the bottom, and we need to remove it from the top as well. So just Control C, Control V, just copy this, and this time remove it from the top. But it's for sure that your data will either be in the bottom or be in the top, right? Because later on we are actually going to push our data from the bottom to the top if it belongs to the top. So in that case, if the data is not in the bottom, then only we have to remove it. And this remove function is actually going to throw an error if the data is not in your bottom container. So we are going to use a try block. We are going to say try to remove it from the bottom, and if it is not in the bottom, then definitely it is in the top. If it is in the top, then remove it from the top, right? Now once you remove it from the top, you will actually have to update your current sum as well, right? This current sum. So we will have to access this current sum variable in our function So I can say non-local current sum, right? This is required because we don't want to just read the value of current sum in the function. We want to update this. So we have to specify that current sum is not a local function variable. It's a non-local variable, which is basically this one. Now we can just say the current underscore sum is equal to current underscore sum minus, we are actually going to remove the element from the top, right? If we are removing it from the top, then we are going to say minus and then take the elements. This is the frequency and this is the element itself. So their product will be something which we are going to remove it from the current sum. So now this function is actually ready. The update function is ready. And now you might have a question that we are not adding something in the current sum or not, or where are we actually going to transfer the data from the bottom to the top? So I will explain you that. But first of all, our update function is ready. Now come out of the update function, create a variable answer, or I would say result. That's my preferred variable name. Result is equal to a list where we are going to push our result or data for our k long subarrays and its x sum, right? Now let us just loop through our elements for I in the range of length of nums, right? We are going to actually process each of our element one by one, right? One, then two, whatever is our array, we are just going to process it one by one. So that's the loop for processing our element one by one. Now the moment I get an element, I would just call my update function. In the update function, I would pass my current element because it needs the current element and the quantity by which you want to update its frequency in the counter object. So my current element is nums of I and the frequency I will want to update it by is 1. I got the element one time, update its frequency. Now what we also want to ensure is our window size should never be more than the value of k, right? This is the value of k. Our window size should never be more than that particular value. So I would say if at any time I is more than k, right, or I would say even equal to k, it means we have actually added an element and our window size is more than k elements, right? Because the value of I starts with 0, it's an index, right? So we will have to take the equal to as well. What I mean to say is the moment I have processed the 6 elements from 1, 1, 2, 2, 3, 4, and now when I process my 7th element, I'll have to get rid of this particular one to keep our current subarray windows, its size equal to or less than k, right? It should never be more than k. So the moment the I is more than equal to k, we actually need to update our data again, but this time we'll have to update our data by saying -1, and we are not updating this particular data, we are actually updating the I minus kth index data, right? Basically we are updating this one and we are saying that this one is now removed from our counter object and the top or bottom, whatever the container it belongs to as of now. So that's the logic, right? Now the next logic is we have to transfer our data from the bottom to the top. So we can say while we have something in the bottom container and the length of the top container is less than x, right? If that is less than x, I think x is x is uppercase, so I would say less than uppercase x. In that case, we will have to transfer our data from the bottom to the top. So we just need to find the highest data in our bottom. So we can simply say bottom dot pop, because the bottom container and even the top container is sorted, right? If it is sorted, then we can just pop the element and it will give us the element which has the highest frequency, right? So what we will get is we will get the frequency, I would say frequency comma element itself, right? Because when we are pushing the data, we are actually pushing the tuple, the frequency and the element itself, right? This should now belong to the top, right? So I would say top underscore x dot add. We're actually going to add the element to the top after removing it from the bottom, and we are going to add the frequency and the element itself, right? Once we have done this, we actually need to update our current sum now. When we remove the element from the top, we update our current sum with this particular logic by saying that our current sum will be reduced, right? When we add something in the top, then we will have to update the current sum again, but this time we will say current sum will be equal to current sum plus whatever is the frequency, that's the frequency, right? Frequency multiplied by the element, right? So our current sum got updated. Now let me actually go back to the drawing pad to explain you more about the solution approach and how this is going to build the solution. Now let me process the next element. Let's say that this is 2. Let's process the next 2. When we are processing the next 2, now try to see the logic. We will first update our data and we will say that for 2, add its frequency by 1. So we are going to go to the update function, and in the update function we are going to check if it already belongs to our counter object, and yes, it is there in our counter object. Then you will have to remove it from the bottom. It is not in the bottom as of now. So it will just go to the except part, because remove is going to throw an error. So we are keeping it in the try catch. Remove it from the top. We will actually remove it from the top. Now this is the element, not this one. This is the element, because this is the frequency and this is the 2. So we are going to remove this particular element from the top. So we can say top x dot remove frequency. Frequency is actually 1 as of now. It is coming from this counter object. Frequency is 1, and this is my current element. So 1 comma 2 will be removed from the top. So let me just delete it from the top, and the moment you remove it from the top, your sum will actually get updated. It will be 4 minus 2, right? Because we are saying current sum minus this. Once this processing is done, we are going to update our counter object. We are going to say now we have 2 times. Add this data in the bottom. So we got a frequency of 2 for the element 2, and that's it. That's the update function. The next thing is, do we have more than k or equal to k elements in our current window? No, we do not have, right? If we do not have, then in that case, this particular logic is not going to be triggered, but this is our next logic. We have something in the bottom and the length of top is less than x. Yes, we have something in the bottom, right? And the length of top is just 1. We need to at least 2 elements in the top, or exactly 2 elements in the top, right? Not more than that. So this particular bottom will actually be moved to the top. So we are going to pop the element from the bottom, push it to the top, and update the current sum. So now this element will belong to the top. How much this is going to contribute to the sum? It is 2 into 2, which is 4. So 4 plus existing sum of 2 will be equal to 6, right? So for this particular window, the x sum is 6, right? But still our current window size is not equal to k, right? We are actually going to have one more logic. Let me explain you that logic. What I want to say is, if the value of I, the current index, if that is more than or equal to k minus 1, it means our current window has at least, or I would say exactly k elements, right? I will be equal to 5, then this condition will be true. When I is equal to 5, that is we have 0, 1, 2, 3, 4, 5. If we are at index number 5, it means we are having actually 6 elements in my current window. So at any moment we have 6 elements in my current window. Now we keep processing the next element. We are just required to have a window of size k. We will keep a track of window of size k, right? So at any moment, if this condition is true, it means now we can push our current sum in our result. So we have a result variable. We can say result dot append the current sum. So I would say current underscore sum, because now our current window is having equal to k elements. We will also just keep removing the extra elements with this logic as well, right? Now, as of now, this is not the complete solution. This might look like the complete one, but if I just say return result, try to submit this. This is not going to pass all the test cases. Let's just wait for the solution, or I would say the result. Yeah, it's judging or something. All right, so it passed almost 450 test cases out of 780, right? It means the solution is close to correct, but something is missing, right? Something is off right now. What is off? All right, let's try to understand this. As of now, we are just pushing our element in the bottom and pushing it back to the top if it belongs to the top, right? Now, what if I just process this element? Let's say we process the element 3, then we process the element 4. Then in the bottom, we will have 1 comma 3 and we will have 1 comma 4. Let me just say 1 comma 3 and then 1 comma 4. Because what will happen? Okay, let me actually update the counter object as well. We actually got 3 1 times. We actually got 4 1 times, right? So now this is our current state after processing 6 elements, 1, 2, 3, 4, 5, 6 elements. These elements will not go to the bottom. The reason being, the condition is, if you want to push it to the bottom, the length of your top should actually be less than x, right? Now, as of now, everything is good. The frequencies are 1. In your top, the frequencies are 2. So you actually have the correct elements, right? Now, if you process the next element, let's say 2, right? If you want to process this particular element, which is 2, so now you have to remove the element which is 1 from your window, because now your window should be this, from 1 to 2, 2, 3, 4, 2, right? So this is my current window, right? Now try to understand this. In your current window, you are removing this 1. So when you remove this 1, the frequency of your 1 will be less, right? It will be 1. The frequency of 2 will be 3, because you got 1 3 here, right? This is 1 2 here, right? So the frequency of 2 will be 3. Now my question to you is, the moment you will actually add this 2, right, you will remove this 1 as well, and when you will remove this 1, your top will not have this element, the element 1, which has the frequency of 2. So let me actually remove this. Let me select this. How to select this? Should be k, and yeah, delete it. The frequency of 2 will be 3, right? So this will be 3. Let me rub it out. This should be rubbed. This should be 3, not okay. Let me control Z. Okay, what am I doing here? All right, now I think we are good. So the frequency of 2 will be 3. Now this is a current window. We also have a 1 in our current window, which will now belong to the bottom for now, right? Now my question to you is, which of these three elements will be pushed to the top? Only one will be pushed to the top, right? All have the same frequency, 111. So actually we are going to push this element to the top. Reason being, this element has the highest data. All have same frequency, so we will use the highest element. And the moment we actually push this element to the top, our sum will be updated from 6 to 10, right? Because we had 6, now we will have a total of 10. 6 plus 4 into 1, which will be equal to 10. Again, it is fine. Our current logic is going to maintain this. If you will see the wrong answer here, you can see that the first window 6 is correct, the second window 10 is correct, the third window also shows 10. It should be 12, right? So for the last window, we are doing something wrong, right? Let's try to process the last window element. So let me just take this element, put it to the next one. So now we got a 3, which is which already belongs to our this particular counter object. So what we will do is we'll actually update our counter object. We have 3 2 times, right? We will also have to remove this from the bottom, right? We'll remove this 1 from the bottom. This will be deleted, and also since we are processing 3, the last element in the window, in the previous window, this was our previous window, the last element will be removed. So this will not be there in the bottom. Remove it from the bottom. So this 1 is now also removed from the counter object, or I would say just take its value as and make it as 0. Now we will also add our element 3 to the bottom. So we will say we got the element 3 whose frequency is 2, right? At this point, our logic is failing. The reason is we are not pushing back this element to the top. Still, this is our top. And why we are not doing it? Because we don't have a logic for this. We just have one logic to push element from the bottom to the top, that if we have something in the top and the length of top is still less than x. Right now the length of top is x, right? Or I would say 2, 1 and 2. We have 2 elements. But this element should actually belong to the bottom now, because we have another element in the bottom which has a frequency more than something which belongs to the top, right? So we will actually keep the top and bottom, both the containers, sorted, right, based on the frequency and the element. So this is our container. What we actually need to do is we need to implement one more logic where we will check that if the smallest element in the top is that less than the bottom. If yes, then just exchange them. So what we need to do is we need to just see that, okay, we have an element which has a frequency of 1 in the top, but in bottom we have an element which is the highest as of now, which has a frequency of 2. So this element should actually be in the top, this element should now be in the bottom. And now you will see that 2 multiplied by 3 is 6, 3 multiplied by 2 is 6, 6 plus 6 is 12. Now our sum will be 12, right? So this is how we are actually going to deal with this particular logic. And how to implement this, we can say, while we have something in the bottom, definitely we need some data in our bottom, right? While we have something in the bottom, and I would say bottom of -1, the highest element in the bottom, if that is more than the top element, right, the first element in the top, that is the lowest element in the top, then we need a replacement, right? So let's do one thing. Let's say that the frequency in bottom, comma, the element of bottom is equal to bottom dot pop. Remove something from the bottom, and the frequency of top, comma, the element of top will be equal to top underscore x. And this time we need to pop something from the top as well, but we are actually going to pop the index number 0, right, the element which is the smallest. Once we have the popping done, we're actually going to do the replacement part. So we can say bottom dot add. We need to add this particular data, the top data in the bottom. So we can say bottom dot add ft comma et, and we can say top dot add, not top but top underscore x dot add frequency of bottom, comma, element of bottom, right? And the moment we are adding something in the top or removing something in the top, we will have to update our sum as well, right? So what's the actual sum which will get updated? So when you remove something from the top, so you can say current underscore sum is equal to current underscore sum minus, we have to say minus ft multiplied by et. That is because we are removing something. And when we are adding this, then we will have to update the sum. So we can say current sum is equal to current sum plus fb multiplied by eb, right? So now we have done the replacement as well. Now let's submit this. Let us see if that can pass all the test cases. If yes, then good. Otherwise, we will see what's the issue. I believe it should actually pass all the test cases. Yes, and now you can see the runtime is really good. The memory used is very good as well, right? So we have solved this problem in, I would say, efficient way, but this was actually hard to solve. And again, guys, I will be honest with you, I actually had to take a lot of help from the current submissions to understand what's the logic behind this. And then I came to know about this sorted list Basically that can be done by heap as well, but I was finding it hard to do it using heap. Using sorted list, it was easily done, and you can see the runtime and memory used is good as well. So I know that this was a long video, but again, if you understand the concepts from everything which I've explained you in this video, then definitely you will be able to solve problems like this. So guys, that's it for this video. If this video has helped you to understand the complete problem, the solution approach, the intuition behind the solution, and again, I'll just keep this solution in the link as a link in the comment, so you can find the solution as well. But the motto behind this is you should understand the solution and the intuition behind everything which we are doing. And if you did, then make sure that you like the video. And if you're not subscribed to my channel as of now, then guys, this was a very hard video to make. Took a lot of effort, so please do subscribe to the channel as well, and I will see you guys in the next video. I want to see you guys in the next video. Thank you for watching this one.